The second half of this lesson is all about polygons and quadrilaterals. A polygon is a closed figure whose sides are segments that intersect only at their endpoints. For example, segments, all these are segments, they don't cross each other, and if I trace it, I end up exactly back where I started. This is made up of segments that do not cross and they're closed. They connect all the way up, or a plain triangle. What would this be? Well, first of all, it looks kind of like a bird cage sitting on a table. And the door is open. There's a little perch up here, no bird on it. Here we have a little bird feeder thing over here. No bird eating. Where's my bird? My bird was a parrot. Her name was Polly. What happened to Polly? Did the cat get her? No. But it's all mathematical because you know what? Polygon. Sorry, that's your math joke of the day. They don't get any better. So there's my polygon. Now, a regular polygon. That one was definitely not regular. A regular polygon has all sides the same length and all angles congruent. So a square is a regular polygon. This hexagon is a regular polygon. All sides congruent, all angles congruent. If a polygon is a figure whose sides are segments that intersect only at endpoints, things that are not polygons would be a star that looks like this. Because even though I end up where I started from, I crossed over the lines. They can't intersect unless it's at an endpoint. Here, that's not a polygon. It's made of segments, but it doesn't connect. It's not closed. Even a plain, simple, that is not a polygon. If I made a giant R for Ramstead, even though it's closed, it's not a polygon because it's got a curve. It's not all segments. So these are all not polygons. Not closed, not segments, and it crosses over. Now, to name polygons, if I have four sides, I've got lots of different four-sided polygons, but we call them a quadrilateral. That's any four-sided figure, polygon. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides, heptagon. Hepta. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. And anything over 10, well, there's 11, there's 12, but if I have a lot of sides, we say it's an n-gon. So if I have 100 sides, I'm a 100-gon. And that's just how they're named. Okay? Would this be a polygon? Yes. Would this be a polygon? No, it's curved. Is this a polygon? Yes. Now, so I've asked if it's a polygon. Now, is it regular? Is this a regular polygon? Are all the sides the same length? No. I can't answer that because it's not a polygon. Is this a regular polygon? Yes. It's regular. All sides the same, all angles the same. Then we have convex and concave. Now, a convex, by definition, a polygon is convex if I can connect any two non-adjacent vertices and stay inside the polygon. So if I connect any two non-adjacent polygons, I will stay inside the polygon. Whereas here, if I connect these two, I'm outside. That makes me concave. What my brain says is this side caved in. That makes it concave. So as I look at these three figures, this polygon, is this convex or concave? This is going to be concave. What about this polygon? Convex. Now we're going to look at individual quadrilaterals and what makes a quadrilateral what it is. Okay? So, we're going to start with a trapezoid. A trapezoid is a quadrilateral with exactly, oh, it would be helpful if you could see, one pair of parallel sides. So those two arrows mean parallel. Now, this is how we normally think of a trapezoid, but we have trapezoids that look like this too, which is kind of like the side of a entry on a house or a little shed type thing. And that'll count as a trapezoid, two parallel sides. A parallelogram, a quadrilateral with both pairs of opposite sides parallel. So two arrows mean they're parallel. One arrow means those two are. And the other thing about this, the opposite sides are congruent. So not only are they parallel, they are also congruent. A rhombus. A rhombus is a parallelogram with four congruent sides. It's kind of like a square that got squished over. A rectangle is a parallelogram with four right angles. Trapezoid, parallelogram, rhombus, rectangle. A square, a parallelogram with four right angles and four congruent sides. Oh my goodness. So, if I made a giant rectangle of all the quadrilaterals in the world, I'd have all my trapezoids. Now, in this one, we're going to have one that we haven't really talked about, but it's called a kite. A kite looks like a kite that you flew when you were a little kid. These two sides are congruent, and these two are congruent, but nobody's parallel to anybody. The adjacent sides are congruent. These adjacent are congruent. That makes that a kite. Then we have regular quadrilaterals, that have four sides that may or may not have anybody the same, and nobody's parallel. It would help if I could draw one. There we go. Might look like that. Those are all those regular quadrilaterals. But inside there, I have every parallelogram. And then we have special parallelograms. We have the rectangles, and I'm just going to abbreviate that because I can't write that small. And we have rhombuses, plural of rhombi. Now, rectangles are parallelograms. Rhombuses are parallelograms. But if a rectangle has four sides the same, it's called a square. If a rhombus has four right angles, it's called a square. So a square is a rhombus, a square is a rectangle. But a square is a parallelogram, and all of these are quadrilaterals. So that's all the quadrilaterals in the world. Now, what they're going to do is give you some pictures of quadrilaterals and say, tell me what they are, and be most specific. So, this picture here, it's a quadrilateral, four sides, and the tick marks mean they're all the same, which makes this a rhombus. We don't know anything about right angles, so we don't know anymore. Here, we have a quadrilateral with four right angles. That makes it a rectangle. Now, if I took a quadrilateral of any sort, and I drew down that diagonal, I would get two triangles. And we would know that these angles would add up to 180, and these three would add up to 180, which means that all four are going to add up to 360. So, 105 plus 6x plus 11 plus 5x plus 90 equals 360. The four angles will add up to 360. Add my like terms, 11x plus, oh my goodness, 195, 206. Did I add that up right? Oh my goodness, can I do that? I hope so. Okay, so we subtract 206. We'll find out. 11x equals 154. Divide by 11. X equals 14. That's quadrilaterals and polygons.